here with Geoff Bowers from Daemon, if I'm saying that right. He gave me extensive lessons on how to pronounce it. And we're going to be talking about secrets from the folks who make the official Lucee CFML Docker images. So as well as that, we'll look at some ColdFusion DevOps tips, why he thinks serverless is so cool these days, and some of the neat apps he's building with Lucee CFML with his team there down in Australia. And also look at tricks they use on migrating legacy Adobe ColdFusion to Lucee. And we'll also do a little bit of chat about WebDev and a few other interesting things. So welcome, Geoff.
Hi there.
And just in case you don't know, he's CEO of Daemon. He's been around for like 22 years, been doing ColdFusion forever, or at least since version 1.
seems like forever. No, probably since version, well, I think maybe version, was it 3.5 came out? I can't remember. But,
in 97 was 3.5? All
yeah,
right.
About the 3.5, 97 sort of time frame.
Yeah. And he's also president of LAS, the Lucee Association Switzerland. So he's that's where the buck stops, as they say in America. That's
where the buck stops, yeah.
Yeah. So right. You guys there make all the official Lucee Docker images. Tell us about that and why that matters to people listening.
Well, I think the first thing to say is in terms of the Docker images, there's a need internally at Daemon, for example, to have a base image that runs Lucee in the best possible way, that we see. And so having built that, we decided to release that as a formal image that other people could download directly from Docker Hub. But there's no reason to have to use the official image. It's just a good starting point for that. And there are other images that are out there. So some people have their own specific images. For example, Orchestration have a command box image, but we run with a very, I guess, clean or vanilla Tomcat Lucee style image. We have 2 images actually. We have one which is just raw Lucee and another which is a compound image that includes the Nginx web server as well, which is probably the most common image that we use internally, but other people use a bit of a mix.
Mm. So does this help reduce problems in getting set up fast on using Lucee, or?
I think so. I mean, the biggest thing with respect to Docker, I think, is a bit of a mental shift to the way in which you build your applications. So in the case of Daemon, our, I guess, brief history and move towards Docker as a deployment pipeline, we've always been very focused on moving to an environment where we can very readily build servers programmatically rather than having to build them manually. So rather than having some kind of Dragon Slayer document which tells you all the individual things that you would have to do to get an image of your server back up and running, we would look to do that programmatically. So write a program which will install the server, everything from the operating system all the way through to the application. And so that discipline for us started quite a few years ago, and we used to run with Vagrant, and we moved all of our production servers, most of our production servers, I should say, to Linux. And so we started to standardize exactly how we would build servers. And that was part of an early desire to have what we call an ephemeral server, or a server that only exists for a short period of time, and to treat your servers, I mean, the expression in the industry is to treat them like cattle rather than treat them like pets. So if you can imagine, in the old days, in the 90s, you had that kind of classic server sitting underneath under the desk. No one really knew what was installed on it, and you used to have to kind of groom it and nurse it back to health on a regular basis, patch it, et cetera, et cetera. So these days, when we look at upgrading a server, we literally just destroy the server completely and build it from scratch. So if you can get to that point, it actually gives you a great deal of confidence and kind of resilience in your deployment pipeline, in that if anything goes wrong, you're really quite confident to just throw the server away and to rebuild it from scratch. And so in the old days, when I say old days, we're talking sort of 3 years ago, you would have to use things like Chef or Ansible or Salt or a bunch of these sort of provisioning programming languages that effectively allow you to code server installations. And you'd use something like Vagrant on the desktop to be able to emulate the server environment in a local development sense. And so really it's a culmination of many different areas that have led to the ability to be able to do this easily. I mean, it used to be only the sort of purview of very large installations like, you know, if you were Netflix or GitHub or someone of that nature, you could spend the time, infrastructure, sort of manpower to actually produce these sorts of environments. Whereas nowadays it's possible for anybody, even with a kind of just an enthusiastic blog site, to have quite a sophisticated DevOps pipeline. So the Docker thing, the reason why that plays into all of that is that even with a scripting environment like Chef, which is a Ruby-based environment, which is the one that we used to use most predominantly in Amazon, it takes about 20 minutes to spin up a new server. So you can imagine to install everything, you have to wait for the script, even though it's automated, you have to wait for that process to take its course from the very beginning. And if you make a mistake, then you find out about that 20 minutes later and you go, oh God. And then you change the script and you can, you know, kick that process off again. So it could be quite, even though it's quite rewarding once you had it finished, quite a laborious sort of process. Docker and containers in general. So containers is a technology that has been around in the Linux community for many years. And Docker really is well, I guess initially a set of tools and a standardized practice, if you like, to dealing with containers that made it much more accessible to people who weren't Linux administration aficionados. I mean, it really was the purview of just a very limited group of people, and Docker really made that a much broader and accessible environment. And now over the last 2 years, it's been a bit of a gold rush in the Docker environment where there are just tools, and lots of different people jumping on board. Even Microsoft has kind of seen the light, jumped on board with Windows containers. And so there's been a massive amount of investment, in, not just in terms of money, but in terms of just sheer willpower, mind power into making Docker a reality. And the reason for that is it makes that ephemeral server technology, that whole scripting your server environment, much easier. So it's an order of magnitude easier to do all of that in Docker than it used to be, say, for example, in say Chef and Vagrant and some kind of cloud-based solution. So Docker makes that concept of a programmatic installation very straightforward, and also gives you the ability to effectively version control your server installation. So we're used to the idea of having version control for our applications and branching and doing different things with respect to an application, rolling back if you didn't like the commits that you made. That type of thing is, while not as sophisticated in Docker, is certainly possible in Docker. So you can have your own images that are incremental changes to the way in which your server is installed. And that is exactly how the Lucee Docker images work. For example, our Lucee Docker images are all based on the official Tomcat image. And so Tomcat, that community, does all the work to make the best possible Linux-based Tomcat image. And then on top of that, we layer all of the installation pieces for Lucee. So we don't try and challenge Tomcat's expertise in that particular area. They choose the underlying Linux distribution, which I think from memory is a Debian-based installation, and then OpenJDK, and then Tomcat on top of that. And there are several different options that you have in that Tomcat environment. And so eventually we'll start to offer the variations in the Lucee environment that are offered in the underlying Tomcat environment. Specifically for anybody who's into the Docker side, we'll be probably looking at Alpine Linux-based installations in the near future. And that's Alpine Linux is a special type of Linux that's being developed for this sort of environment, in that it's extremely lean. It's about 5 megabytes or something in size.
5 megabytes?
Yeah, very, very small. And then you would add to that incrementally the packages and things that you need. So it's designed for this type of distribution and installation. So,
last time I installed an operating system from a company in Seattle, it was gigabytes.
Yeah,
just eats up stuff.
Well, it is a very big difference. For example, if you wanted to do a Windows Docker container, for example, which is sort of possible with Windows containers, is a little bit behind the 8 ball compared to Linux containers. I think I don't know what the comparable base OS options are. I mean, effectively, Docker shares and utilizes the underlying operating system. So if it sees anything that it needs already, it doesn't bother to download it again. It just uses that layer. I don't know at what point the Windows container kind of kicks in. And so Windows containers are not sure in terms of what size they are. But certainly in the Linux environment, it's very interesting in terms of your ability to make these changes. If I want to do a Lucee upgrade, for example, I make a couple of text changes and then redeploy, and it's done. And it can be done in seconds. It doesn't take even minutes. Really, the time it takes is the time your server hosting Docker has to download the new image and slot it in like a cartridge, and then spin up the containers. It takes a few microseconds to get that running. So it's pretty cool. And I think that again, though this is a bit of a ramble around, but the whole purpose of doing these things, the whole purpose of moving to an ephemeral server-like infrastructure, is back to this concept of resilience of your deployment process. You want to have absolute confidence that when you're deploying something, it's not going to break. So we often think about that in terms of the code changes we make. So we make a couple of code changes, add a new feature. You want to test that and make sure that it's not going to break anything when you deploy it. But probably, I think, a greater risk to deployment problems and the like are when we make changes to the server environment that surround that code. So we're making configuration changes, or we need to add an extra module or an extension or something of that nature, which is harder to replicate for a start in your local development environment, and can have kind of far-reaching implications in the server environment when you go to make that deployment and that change. And what's worse is it's very difficult, typically in an old sort of legacy infrastructure environment, to roll that back. I logged on remotely to my Windows box and I clicked a few checkboxes with the mouse. Everything seemed to be working okay, but in the middle of the night, all the alarms are going off and the servers are dead, and nobody really knows or even can remember what you actually did at that point. Was it this checkbox I clicked, or is it something else, or what the hell happened, or I forgot to replicate it across the cluster, or whatever. Whereas when it's programmatically done, it is what it is. And if you roll back, you're rolling back to exactly the installation, right down to the nuts and bolts of the operating system that you had previously. And so that ability to roll forward and roll backwards gives you that confidence to have a move towards, which the true goal for Daemon, at least, is a sense of a continuous delivery. So in other words, the ability for a developer to have an idea, make a change, and have that move into the production environment in the shortest possible time. That doesn't always mean that you make a change and you immediately deploy it, like it's instant that you're going to do it that day. It's just that you have the option to do that, not only in terms of time frame, but in terms of the confidence. Even as a new developer, I can make that change. It'll go through the pipeline. It'll end up in the production environment. And if I really did do something catastrophic, that can be very easily rolled back and go back to the status quo of where we were before a moment earlier. And that, just having that knowledge in the background, gives you a huge amount of confidence when you look to roll out new changes or complex changes or infrastructure changes. And that's the first kind of stepping stone towards an automated infrastructure, and why Docker is so popular. The next step, and I think I talked a little bit about this at CF Objective. I had 2 talks. One was what we do at Daemon in terms of actually running a development environment. And the second one was how we go about deploying that in the real world out into a production environment. So often people will play with Docker, they'll have that running locally, they'll get a little Lucee server spun up and it all seems like magic. But then when they go to deploy it into production, there's a whole other set of headaches that they need to consider, or they're perhaps doing it wrong. They're logging onto the box and they're pulling the Docker images manually. And so the next step is this whole orchestration piece where you can click a few buttons or programmatically do it. and instantly you get, you know, from one container to 16 containers, all running in a cluster, all spread across multiple data centers, the sort of stuff that, you know, you kind of dream of even 5 years ago, that this was just an impossibility. The thought of being able to deploy something and then scale it across multiple data centers just with a couple of command changes was really, again, only available to the very largest engineering teams. And now it's literally available to anybody, even with just a simple blog. You could easily do a clustered blogging solution and have that running up and down. We do that with pretty much all of our clients now, even the very smallest client, because we have a base image in Docker, which, you know, always offers the kind of standard installation. And then we have a standard set of libraries that sit on top of that for our applications. Typically, we work with a framework in ColdFusion called Far, which has fallen from favor, I think, in recent times. You know, there's a lot of boxier style frameworks that are very popular these days. But nevertheless, that's the one that we enjoy using. And it means that when we go to deploy something, that even though it might be a simple, let's say a simple content management environment, it's immediately clustered. So it starts in a clustered state. Even our simplest clients, we typically run as 2 containers just because that's a standard for us. And those 2 containers will automatically find themselves going across a larger cluster into different data centers in a kind of high availability mode. And again, this only possible because of the advances that we've had in things like cloud infrastructure. I mean, we're predominantly in Amazon at the moment, and it's, if you, let's say, think you had a database, typically we use MySQL or MS SQL, but let's say it's a MySQL database. If you wanted to install that, manage it, then cluster it, and then have it split over 2 data centers and handle all of that kind of infrastructure, if you like, that's a lot of work. That's a dedicated systems administrator just to be able to kind of pull that stuff off. And it's a fairly unique sort of speciality. You know, it's a MySQL clustering speciality. Whereas in Amazon, I can go, give me a MySQL instance that's this size. Yes, I'd like to have it clustered across multiple data centers. I don't care how that's done. Click the checkbox. And it is literally a checkbox. You just go click and you go, I might like some read replicas because it's, you know, it's going to be the Olympics or something and it needs to scale. So I'll click read replica times X and they just spring magically into being. No idea how it happens, where it goes. It just works. And it's that type of infrastructure on demand that really makes these overall DevOps pipelines for smaller companies an absolute reality. I mean, of course, we know a little bit more about MySQL than I imply there, but you really don't need to know anything more than that. And you can select the number of backups, you know, how far those snapshots will go back in time. All of that administrative caper, the maintenance, the upgrades, it's all managed by somebody else and at a price point that is frankly just ridiculous. I mean, you know, I mean, if someone like me who, you know, used to look at deploying physical servers into data centers 10 years ago, I mean, geez, these, you know, this is 2 minutes and you have something up and running. Whereas before it was 2 weeks, you'd be lucky if Dell or somebody actually shipped the physical computers into the cages in that sort of time frame. And then you had to have a man on the ground, wire it all up. And I mean, it's just completely different, like thousands and thousands of dollars difference in terms of price. So even if you're not going to Docker and you're kind of on the more server image based side, you know, like the web app guys are looking at a Lucee gold image for AWS and AWS AMI. It's a very big change to managing your own infrastructure. And if you take the next step, which is containerization, and the reason why that's a little bit different is we don't have a server which is dedicated to a client for smaller clients. We would have a cluster we call, I think our cluster is currently called Cloud 8. It's almost at Cloud 9, but not quite so. So it's Cloud 8 sits out there. It's got about 4 servers split across 3 data centers. And when we do a deployment, the orchestration tools just choose where those containers will fit into that cluster, whatever has the most space or is the kind of least used resource-wise. Again, these are all decisions we don't have to make anymore. It's automated to a large degree. And for larger clients, they'll have a dedicated cluster. It's cool. I mean, you think about, you're paying for servers by the minute. This is another thing that's also quite interesting. And so we have staging environments, which programmatically start up in the morning at 8 o'clock and then shut down at 8 p.m. And that's just automatic. You can override that and say, no, I'd like the staging cluster to stay up a little bit longer. But you can just cut 50% of your bill by automating that process, because again, you don't really care. Okay, it's going to take 10 minutes to start those servers and another couple of minutes to deploy all the containers across them. But that's happening while I'm, walking into work, getting a cup of coffee, all the staging servers are coming up, and I don't even know about it. I get a couple of messages come through on the Slack channel saying, everything went according to plan, or in the rare occasion, things didn't quite go according to plan, and you can sort of sort that out. So yeah, it makes life a lot easier, especially for companies like Daemon, which are running a lot of different applications, supporting a lot of different applications that are quite varied. Normally we think about DevOps pipelines as being very intimate kind of affairs. The application works in a certain way, and to update it, you have to sacrifice a chicken and FTP something into place. There's a whole kind of ritual that you often go through with larger scale applications to make a successful deployment happen. And what we've managed to do with Docker environment is to effectively sandbox all of that kind of intimate stuff into a container which is standardized, and it sits in a kind of universal format, whether it's on your development environment, on the staging servers, or whether it's sitting in production. And that makes a very, very big difference and an impact to the way in which we develop day to day. And I should say it's not just Lucee. This is other languages that we work with. They all work in the same way. So we don't have to, we might have to, in some instances, unfortunately, manage a PHP solution. We've got a few of those that we look after. And it's the same DevOps pipeline for that. So we make those changes. Obviously, it's a slightly different environment for development, but the actual rollout of the application, the way it's routed, managed, clustered, is extremely similar. And so that means that, everyone, it gives a chance that everyone on the development team can start to get a handle on that sysops process that was otherwise a kind of a mystical black art in the old days. That's why you had systems administrators. I mean, those guys did really cool stuff. And effectively, this is encapsulating a lot of the work that they used to have to do into something that can be programmed, and so leave them to do more interesting things like serverless development, that type of stuff, which is something we could move on to at some point in this talk.
Yes, we will be talking about that in a few minutes. So this is amazing stuff, Geoff. Thanks for sharing all these secrets about ColdFusion DevOps using Docker containers. And we'll link in the episode I did with Patrick Quinn, who's the product manager for Lucee. And we talked extensively about AWS in that episode. So
yeah, they're doing great work. They're doing great work, those guys.
They are. So the other thing that occurs to me, and maybe it was implicit in something you said, is, I remember in the old days, you were always patching the server, the operating system, or putting a hot fix on ColdFusion. You don't have to do that anymore, because you just download, you just tell it to use a newer version, pull a newer version into the image.
Exactly right. And in fact, one of the things that you look at patching, it's not just patching the CFML engine, it's also patching Tomcat or patching the underlying operating system. All of those things are quite arduous. I mean, if you're not used to patching the operating system, for example, that's something that can very easily get out of date, or Tomcat, or, I mean, the amount of legacy apps that we see sort of thrashing around on something like Tomcat 7, because people are just too terrified to kind of upgrade everything to the later version of Tomcat. That all kind of vanishes in a Docker environment. You can test all of that locally in dev stage. You can have that running, well in advance of having to do it before you go to deployment. So it's not like you're just throwing a switch and it's out there. But when you actually do the upgrade, you're right. It's really just a simple text change of about, I don't know, it'd be half a dozen characters. It'd be from Lucee, the new version, and that'd be it. And that if you just used our own internal Lucee image, every time there's an official release from Lucee, we typically upgrade everything at that point. So we'll upgrade, there'll be an upgrade to the operating system, OpenJDK, Tomcat, and then Lucee on top. And sometimes if there's a lengthy period of time between releases of Lucee, we'll actually release an interim image which has just the operating system and Tomcat upgrades. And another cool thing about, well, Linux environments in general, but also the Docker environments, is all of the major Docker registries like Docker Hub or Key.io is actually the registry that we use internally at the moment. They have security scanning options which will scan your images and tell you all of the known vulnerabilities that exist in that particular image. It's a bit terrifying because there's always vulnerabilities. And you go, what? But it's literally those things that are known vulnerabilities for which there are no fix. That might just be, you know, if somebody had root level access that they could do something, or if they had user access at a kind of a command line onto that server that they could escalate their privileges. Or what I mean is there are a lot of issues that might show themselves in a security scan like that that wouldn't necessarily be relevant to a web app. You know, if somebody's got command line access to your application, then there's probably a few other things that have gone wrong with your web application before you were worrying about that particular exploit. So, but it is good because at least you know what the potential problems are. Whereas currently most people just have a kind of willful blindness to, you know, what issues might potentially exist on the whole stack. Forget the little tiny, literally tiny layer, which represents the CFML engine on the top, and your own application, which is obviously a very large vector for attack. The underlying operating system is generally not looked at hard enough, perhaps.
and not just the patching, but how it's configured as well. Yeah,
so configuration, all automated as well. So you make all those changes, you decide the sorts of things that you would like to have implemented and updated. And then when you roll that out again, you've got that opportunity to say, oh, it's working perfectly. And if something goes wrong, instantly roll back to the previous configuration that you had in place. So yeah, I think it's important. When you seal a Docker image, it's like an appliance. It's got all of your pieces sealed into it. It's not like you roll it out and then FTP something into place. It's already built with all of your code in it and everything kind of running in it to start with. So you're literally just shifting from your dev environment to stage environment to production environment, a kind of hermetically sealed version of your app at that moment in time, and you deploy it. And so it's works really well. Love it. Cool. I have to admit, there is a barrier to action to get into Docker, and you have to have an application that, you know, doesn't write files locally. There are a few kind of issues with converting to Docker. Writing files locally is an important one because imagine if you write files locally and then the image is destroyed, you've lost those files. And so you need to be able to maintain state of your application. If you do write files, let's say it's an image or something, in a CDN or some kind of shared media resource, little things like that. Once you get over that sort of hurdle, getting into a DevOps pipeline, and we do this for people, if we were, let's say we were commissioned to help people establish a CFML DevOps pipeline. We do this for other languages too, but essentially we normally have an engagement about 5 days to implement something. So that gives you a base kind of core pipeline, which you can work straight away. And then you probably need a little bit longer to get the team into the kind of mental mindset to actually use it, because you have to develop in Docker, build in Docker, deploy in Docker. And once you get past that, you know, the issues that the sort of advantages that I've described are immediately available to you. But yeah, I mean, that's something that we, you know, a bit of a plug for Daemon there, but that's something that we do to help people move into that particular area.
Sounds like a really useful thing there. So you mentioned serverless earlier. Yeah. Tell us a little bit about that.
So you had if you think of it in terms of, there was a beautiful image that somebody, whose name escapes me now, put together, which had, in the 90s, we had spaghetti code. And then we moved through into the kind of noughties, and we had lasagna-like code where everything was put in layers. You know,
this was Brad.
No. I had this in my presentation as well. I'm sure others have, because it's a great image. There's some guy who runs a startup. I can't remember. Anyway, so the lasagna thing is this N tier cable. You know, your web tier, your app tier, your database tier, that type of thing. And then you move to a ravioli based, stay with me, the ravioli based server architecture, where everything's nice little packets of pasta with goodness inside. And these are the kind of microservices architecture, or a Docker-like architecture. Do you know what I mean? So it's a nice dish, but the dish is made up of lots of little packets of things working together. Okay, so serverless is the next step beyond that, where rather than having to have a microservice that you run and deploy, you would have something else that you either invoke as a service. So in other words, and this is strictly speaking, not serverless development, but we look at it in a similar way. If you went to Amazon and you said, I would like to have, I don't know, I'll give you a classic example of what we're working on right at the moment. I want to do video transcoding. So we have some very large installations, big university client here, where we effectively run a YouTube for the entire university. They have some problems with the Patriot Act and a bunch of other things, which mean that things like YouTube or other external services that run outside of Australia are not possible for them. So they made a decision several years ago to build their own media services platform, and we were the company that put that together for them. And initially, we had a whole cluster of servers running FFmpeg, doing transcoding. So we're running the servers, we're putting the cluster out there, we're sending it, you know, you've got a message queue that tells the cluster to pick up a new video for transcoding and transcodes it, et cetera, et cetera. But you're running and maintaining all that infrastructure. We're moving that to Amazon now, where Amazon have a transcoding service. You don't even know what it does. Pop the file into somewhere in S3, it picks that up, transcodes it, and a new file appears somewhere else. So that whole process, effectively, you're not managing a server or doing anything, you're just calling upon a service that runs and processes that. And you can take that extension slightly further, where you can now write applications where it just performs a function, does a function. And that function might be, in the case of what we do, it might be to see that a new video has arrived for transcoding, to update let's say a dashboard or a content management interface, if you like, to say, yep, this video is here, register the video, pick up some metadata about that video, and then move the video file into an area to be transcoded. And then when the transcoding finishes, we have another function which just wakes up and goes, hello, video is finished, everything seemed to go okay. I will now update the database to say this video is available, this is where it is, you can continue. And so in that particular environment, there are several different components. One is a Lucee application, interestingly enough, that runs all of the web interfaces, you know, provides the opportunity for a user to interact with all of that interesting infrastructure sitting behind the scenes. And then there are a series of what we call Lambda Functions, which is Amazon's serverless technology, which I believe are running, I know they'll shoot me if I get this wrong, but I think they're running Node at the moment. So one of the languages that we work in, JavaScript and Node. And they do they're not like apps, they're just very specific functions. They just do that function. And there's an event that fires, either we put something onto a message queue, or Amazon has its own event infrastructure like file created or something like that. And it immediately fires that function. And Amazon's responsible for spinning up that node environment, making sure that that particular function is in place, executing it, and then shutting it down. And essentially, you're just charged by effectively the usage that you have rather than anything else. You're not charged for the service to sit there permanently. You're just charged for how many times it's actioned and activated. And so we're moving all of that video transcoding from an FFmpeg farm all the way through to a combination of Docker-based Lucee apps for managing everything, and a combination of serverless functions and Amazon's transcoding service for providing all of that transcoding. And they do quite a bit. I think they have about 16 terabytes of video data up there at the moment. and other things, images, files, audio. We manage all of the media assets for their Moodle installations.
Wow, that's a lot of data. Is it really expensive to use this Amazon transcoding?
Well, it's not. I mean, compared to running, you imagine you've got a server farm that you're running permanently. I mean, you can predict to a certain degree the amount of traffic or volume you're likely to experience. So during exam time or during assessment time, many of the courses at the university now accept a video submission as an accessible, kind of item. And so you have to have the ability to be able to receive that video as part of that student's assessment criteria, and then process it. So you know that everybody waits until the very last second to submit their particular assessment. And so you end up with a kind of mad rush at, say, midnight, where everything has to be uploaded and processed. Whereas the rest of term time might be a very small kind of trickle for that particular subject area, for example. So for a certain degree, you can predict the amount of scalability that you might require. We tend to just have it all sit in a queue, and if the queue gets too big, we'll automatically scale the servers. But in the case of the Amazon infrastructure, you only pay for what you use. So if there's a huge burst, it'll suddenly do this kind of massive parallel transcoding of all your video, and then it'll just go back to nothing. And so you're relying upon, I guess, the overall kind of resource consumption of that Amazon data center, which is typically much larger than our own set of servers that we have in place. I mean, there can be some bottlenecks, but as I say, everything we have queues and then gets processed. But Amazon we're in the middle of that rollout, so it looks to us as though Amazon's much more efficient at managing the scaling than we are. I mean, it takes us time to respond to the queue, all that sort of business. So we're really impressed. I mean, that is something that we've done for a couple of clients already. So we did that for the Olympics. We do all the public-facing infrastructure for the Australian Olympic team. We moved them out of Bright Cove and pushed them into Amazon. We've got university here, which is all our own FFmpeg farm, which we're currently moving. That's a massive installation. And then we've got a couple of other clients in the pipeline to make that video conversion, because it is much less expensive, because you only use, if you imagine like having 16 terabytes of data, I'll just pull that number out there as a kind of example. If you had to run that on your own network storage, that's expensive. And if suddenly you need to add more disks to that RAID array, that becomes very expensive. Whereas S3 in Amazon is highly durable, very, very high availability, and is comparatively inexpensive. If you've got all of your assets are under 5 gigabytes, it's very inexpensive. So it's hard. It's compelling. I mean, we spent all these years trying to get away from vendor lock-in. So, moving everything to Linux and trying to containerize everything so that we wouldn't have to be dependent on any particular vendor. But Amazon offers such great options that it's difficult not to go, I could just use this service. It's really nice. But if you wanted to move to somewhere else, that service wouldn't exist. You'd have to replace it. So to a certain degree, there's a bit of lock-in, but it's very inexpensive compared to doing it on your own.
I know. I was talking with Brian Klass about all the AWS stuff you can do, and apparently there's over 40 different services now they offer, and transcoding is only one of those. So, and he was also telling me about the Amazon conference, and I'm forgetting the name of the conference. But anyway, they have 1,000 sessions at this conference. I mean, it's crazy.
Even here in Australia, we're only tiny, and we get like, I think they had thousands of people attending just a conference here in Sydney. I mean, it is huge. And the other providers like Azure and DigitalOcean and others are they're pretty good too, but they just don't have the breadth of services. I mean, it is you now, when we look at it, we do a deployment. We pick up a bunch of EC2 servers for our Docker environment. We don't even do Memcache anymore. So we have an Elasticache installation that's an AWS service. It spins up across multiple data centers. We can use Redis or Memcached if we want to in that particular environment. We use their cloud search product now, which is a kind of what is it? I think it is still Lucene based. Can't remember, but it's a great service. We index everything through that service and have the search results come back. There are heaps of things that we do now that are just part of our standard deployments. It's so easy, and so we can suddenly give a client this extremely high-end, high availability, absolutely top-grade infrastructure solution, and it doesn't cost us that huge amount of consulting effort that it used to in the old days to actually just get it running, let alone managing and supporting that infrastructure the moment it's deployed. So yeah, it has really revolutionized the way in which we can address applications. Even the simplest applications. Used to think about, we've got a couple of startups that we're involved with here in Australia, and you think about, you shouldn't be thinking about scalability initially. Well, it's hard. It's hard to, because you're trying desperately on a kind of a shoestring budget to get things done. And so trying to think about, we've got to do all this extra work to make it hugely scalable. It very often not part of people's thinking. It's like, when we get the scale, we'll now have to reinvest and get rid of that technical debt and scale. But for us, even that, we don't have to worry about that. I mean, our standard deployment, even for a simple solution, is scalable. And so it gives us this kind of, again, the confidence of being able to go, okay, well, we can do that, we'll do this. And it's automatically, we have to go out of our way to make it not scalable. Yeah, I mean, everything we're using is something that is automatically something that can be deployed in the cluster. And so we have to make a conscious decision to use something that won't be. And sometimes you have to. There are some services and things that you, for example, we run an ebook distribution thing called Boxer Books, which is a startup that we're involved with here in Australia, selling ebooks to secondary schools. And we have an Adobe content server that runs all of the digital rights management. And so that's a single point of failure, if you like. But we don't, I mean, it's pretty robust, don't get me wrong, but it's not something we'll look to cluster until such time as, we have a huge amount of volume that might require it. But everything else is, is fully distributed, high availability, all clustered, and we're in that kind of startup phase. So great, it's really, really, really good.
So I'm guessing you've migrated a lot of legacy Adobe ColdFusion apps to Lucee CFML over the years.
Yes, that would be true. I mean, I think the vast majority of our stuff now is Lucee based. We still do have a number of Adobe ColdFusion clients. They tend to be in a situation where it's less expensive for them to just keep upgrading, or to not upgrade at all, which is even worse, but to keep upgrading than to make a migration. And so to make a migration is, it's not just a case of getting the code to run on Lucee. I mean, that is actually probably the easier part, depending on the type of application that you're running. There's a lot more involved. So, whoever's involved in that infrastructure, the systems administrators, everybody in that environment needs to be comfortable with a move to vanilla version of Tomcat, running Lucee. What might be the problems and complications? Better the devil you know than the devil you don't. That type of issue. But the actual code changes tend to be relatively minor, depending on the sort of things you use. So, for example, if you're very heavy PDF users using PDF forms and the like, Lucee doesn't have a huge amount of coverage in that particular area of CFML, and so you might need to look at wiring in some sort of an external service, or potentially rewriting those particular areas of your application to adjust the CF reporting module. That's a big part of what you do. If you have all of the UI elements, is there CF windows, CF crazy crack smoking menu, things like that. If you are unfortunately in a situation where you're bound up in those sorts of tags, which we don't support, so as by principle we don't support the UI elements in Lucee, then your migration might be a little bit harder than normal. But generally speaking, it's pretty straightforward. I mean, the coverage for CFML compatibility is very high. It's a core priority for us. So if we see incompatibilities, they're treated As long as they're not, things like CF window, etc., then we treat those with a high degree of priority. And yeah, I mean, we have obviously most of our apps. No, it's not true. I would say many of our apps have migrated from Adobe ColdFusion, but we are still building lots of new apps. Lots of greenfield projects that are started with Lucee. So we're not just in that kind of maintaining legacy mode and reducing licenses. We actually use the product because we find it useful as a tool for building new stuff.
That's great to hear that you're creating lots of new ColdFusion apps. So that's a good story to get out there.
Unbeknownst to many people.
Indeed.
I mean, it used to be a, there's a kind of I hesitate to say, a sort of a stench attached to CFML in recent times. This old crack smoking language that no one would use. Whereas obviously a very modern language, which has many, if not all, of the features of other languages, and also a kind of a unique approach, which I think is very well suited to web app development as opposed to development in general. And there's been a bit of people have come off the high horse of it has to be, language purists, certainly in terms of who's paying for solutions. These days, we tend to not get the question, what's the technology platform? If we're asked what the technology platform is, we actually literally say it's Linux running Tomcat with an application framework on top. We don't even get to the point of mentioning the specific language or framework that is being deployed. From the client's point of view, it's more of okay, if I have to maintain it in our infrastructure, what will we be managing? And it's, Linux, Tomcat, that's really what they're managing at their level, the application we're managing at our level. And they're more interested in the solution and the result than they are in the underlying technology. Whereas 10 years ago, I guess, the height of the .com boom, that type, people were very, we're going all .NET or we're going all Java, or they were very focused on specific language decisions. And these days that seems to be less important. I mean, one of the things that always surprises me is, every year we go through an assessment of Daemon as to whether or not we will continue with CFML as the preferred language platform for what we're building. It's a serious question. Should we do that? What tooling, what other tooling exists out there? What should we be considering? And we don't just work in CFML. So we work in a range of different languages, from PHP, Go, Python, JavaScript. These are things that not all of our apps, but many of the peripheral things that we do involve those sorts of languages. And so for us, it's not really a decision about only sticking with one kind of language in a purist sense. It's Lucee works well for us. It's a good utility. It does web apps extremely well. We have a layer of libraries within which we are very productive. And while that continues to be the case, we will continue to enjoy using Lucee. But in those areas where it's not appropriate, so for example, writing a serverless function to process video transcoding off an Amazon queue, we will choose a language which is more specifically suited to that particular environment. And I know many shops would just, build a CFC in ColdFusion and cobble something together on the side of that kind of monolithic server that they've got in place. But when you break that down and start to look at a more microservices architecture, you're really just saying, okay, well, this piece here, we'll put that in a little container or a little serverless function, and that'll do its job really well. And we'll choose a language specifically for doing that job really well. And that's generally the way we like to look at it, rather than seeing it as kind of only the one, what do they say? You got a hammer and you use it to bang everything or whatever it is. It's a tool that works extremely well for web app development. And certainly for us, we're comfortable, familiar with it, and it still continues to be, very successful for us. And while that is true, we will continue to use it. I mean, I note things like, interestingly enough, when we were looking again this year, earlier in the year, Ruby. What's happened to Ruby on Rails, for God's sake? That stuff's it's got a stench like other languages I've heard. Isn't it strange? I mean, from being the darling of the web development community to now being your independency hell, and Ruby bundles are a disaster. Every language has its own particular challenges. And, I've seen beautiful things written in Ruby and not so beautiful things. But
Indeed.
it's just this kind of flavor of the month business, isn't it? I mean, I don't know what'll be the next flavor of the month. Probably it's Node. Is it Node's flavor of the month at the moment? I wonder how long that will last. But again, you've got to use the tools that work for you. It's more about the solution than anything else, and the maintainability of it.
So tell us about WebDU. That was a conference down under in Australia.
WebDU.
Yes,
It was
great conference.
Close to my heart. I can't remember which side
yes.
it's on this time. So WebDU was something in the .com crash back in kind of 2002, 2003 sort of time frame. We used to go in the boom. We used to send people overseas to conferences, and you know, I was fortunate enough to speak at the very first Alaire conference in Boston, and you know, we were part of that whole sort of vibe around the community and sharing your technology and your knowledge, that type of thing. And when the crash came, that became very difficult. You know, people were it was literally a boom bust sort of cycle where, you know, people are driving a Ferrari one day and the next day they're on the street, everything's gone, literally everything. And it was a much tougher time. And so one of the things we thought would be good would, if we can't take the team to a conference overseas, that we would run our own conference locally. And as it so happens, Sydney seems to be a fairly popular destination for people. And it was surprisingly easy for us to encourage really top-notch speakers to come all the way out to Sydney on a kind of a, you know, a holiday, which they would incorporate the conference. And so we did everything in our power to sort of treat speakers like rock stars that they are, and to kind of build a conference around that sort of notion of community. And it was never a kind of a for-profit thing. It was always, sometimes we made quite a bit of money, but we nearly always spent it all. So we would have outrageous parties, and it was a bit ridiculous at times. But we had a huge amount of fun. And I think certainly everybody that I talk to who reminisces about WebDU, it was a different time, and it was a different sort of conference. It really was about having a fantastic exchange of knowledge, information, networking, and generally a kind of a good time in a period of time that was, you know, less wonderful in reality for people, you know, when you had to go back to the office and fight your way through the crash time. So that was the kind of vision of it. It ran for 10 years, and didn't kind of peter out. Really, we had 2 young children at the time, 2 and just newborn. We just couldn't continue. So it's a huge amount of effort to run a conference like that behind the scenes. There's a lot of, it's a huge amount. I mean, if you've got 20, 30 speakers, you've got to chase them all up, provision them with everything they've got. Then you've got all the sponsors. It's a really, to do it well, a conference, it takes a lot of time.
Yeah,
and
it's
so
a full-time job.
It is a full-time job for people who weren't running it full-time. And behind the scenes, you know, my wife used to do a lot of that kind of heavy lifting for us, plus a couple of the people in my company that used to do that. And we all had young kids, funnily enough, at the same sort of time. So now Isabella, my eldest, is just about to turn 8, and James is 6. And so, you know, 5 years has gone by, and we kind of reminisce, maybe we'll do another WebDU sometime. I don't know. But it certainly was a wonderful time. And I would love to see another conference spring up that had the same kind of ethos that WebDU had. But the location, it's such a good location that they say. I mean, it's much easier to get people to travel to Sydney as a speaker than it is, say, to travel, I don't know, to a destination that is less wonderful or less kind of fantasy land. So anyway, that worked well for us. I still travel to conferences overseas on occasion. I was recently at CF Objective in Washington DC, I should say. It's obviously different to Washington State. We don't think of Washington State out here. We literally, Washington to us is just the capital. But that was good. That was interesting. For me, conferences are less about the attending the sessions, although there's some sessions I do like to just sort of see where we're at. You know, are we behind the 8 ball? Are we ahead of what people are doing? It's good to kind of give a feel for, where you kind of sit and to get a broader perspective on different ideas that are out there. But I like the meeting the people part the best. So for me, CF Objective was great because I got to catch up with a lot of the Lucee Association Switzerland management team. I was there with Gert and Patrick and the guys from Ordis, Brad and Louis, and it's good to be able to meet people face to face, even if it's only briefly, just to say hello and to continue that connection. Funnily enough, I met up with a company in Washington that does Far Cry development. So that was also very interesting. And I had a bunch of clients that I visited. I went up to Farmington, Connecticut, and a few other kind of destinations for just catching up with the US-based clients that we have. So again, it's more, for me, it's more about meeting people than it is necessarily that sort of technology that people are discussing. But I do like to hear about the technology. I gave 2 talks on Docker, I think, as I mentioned, which more and more people are getting into. So yeah, it was good.
It's the wave of the future.
It's certainly a particular, it is a path to the future. I don't know if it's the only one, but it's certainly worked very well for us at the moment. Yeah.
So I've got a bit more of a personal question here, Geoff, if that's okay.
By all means.
Your company's named Damien, and it's a somewhat unusual name. How did you come up with that?
Well, okay, it's really demon, like
okay,
like encyclopedia or hemoglobin, and it's the kind of it's not spelt like that in America, but it is spelt like that in the UK, which is where my sort of formal education was from. It was going to be originally the company we tried to name as the Poppet Proprietary Limited, Poppet, P-O-P-P-E-T, but that didn't work out. Then I wanted Bugalugs Proprietary Limited, and that Bugalugs was taken as well. So both of those crazy names were taken. So then I had a thing for Greek mythology and the like, and there was always the demon of Socrates. There's no one man could have so much knowledge. You had to have some kind of divine intervention, some kind of assistance. And so a demon's like a kind of a less the kind of Christian devil like thing, and more a deified hero or someone from the underworld who might communicate with you. And also in the same twist was, as you're probably well aware, the name of a process that listens at a network port unattended. And so you have a mail daemon, an FTP daemon, a web daemon, etc. So it kind of fit well with my own mythological, classical leanings and the technical side of things. And certainly back in '95 when we started Daemon, this was less of a popular name than you might have imagined. Nobody, it didn't come up into any conflict in terms of web search engines or anything else. These days, yeah, it's probably a little bit more common than I would like. Back in '95, interestingly enough, one of the biggest battles I had was trying to convince people that the internet was a thing. So I'd be out there competing against, because I was a stockbroker or really a derivatives dealer prior to getting into setting up an internet company. I'd always been into programming, but when I went to university, there was no such thing as a computer science degree. I think the closest was maths and computation. But I did biochemistry and a lot of computing in trying to work out and do nuclear magnetic resonance, X-ray crystallography, things like that, very computer heavy. So getting into the internet side of things, it's Microsoft Network, it's CompuServe, it's Bloomberg Network. I had a fascinating meeting with Mike Bloomberg, of all people, when I was a stockbroker. They had just installed Bloomberg terminals throughout the entire office, and Bloomberg themselves had bought a floor in the building that we were in. And so we were all invited upstairs for cocktails. And of course, Mike Bloomberg was there. And I was, must have been, I don't know, 22, 23, something like that. And I was in this animated discussion with Mike Bloomberg about how the internet was going to be a wonderful thing. And he was telling me it's dead on arrival, and it's all about commercial networks like Bloomberg's network, etc. So it just goes to show even the greats can get it wrong from time to time. And an interesting little anecdote. But,
wow. And I know on Twitter you're Modius. Is that another classics reference?
Well, sort of. A modius is like a hat or a measurement of wheat from Roman times. But really the reason for that is that when I first got my my university account at Oxford for access to the internet, you had to have some bizarre 6-character plus number. And I think I was going to end up with something like, you know, PH15832Z or something ridiculous. And so I was like, for the love of God, I must be able to have something. They said, oh, well, if you can give us something now and we'll see how we go. So, you know, things like Gandalf and Skywalker and every possible name you can imagine had already been taken. And so Modius was just something that sprang to mind. It was short, just fit the character limit for the smallest possible one. And that was my account. And so back in, would have been 89, 90, that sort of time frame. And that's been my account forevermore. So whenever there's a new service, I have to race in there, get the Modius before somebody else does. But yeah, so.
Well,
Modius, a bit weird, a bit strange.
I was always curious. So let's just wrap up with what I've been asking every guest on the podcast, which is, why are you proud to use CFML?
Proud to use it? Well, I would never put it in those terms. For us, it's a tool. It's a tool that we think works particularly well for what we need. And so while that's the case, we'll continue to use it and use it in anger, if you like. But I don't think we have that emotive kind of attachment to it. I just think it's a good tool, and while it remains a good tool, we'll continue to use it.
Cool. And then, you know, we alluded earlier that some people have said that ColdFusion has been dying for a very long time and it's still alive and doing well. And as you've been saying, you know, you're doing new sites with it, you've got lots of clients, it's thriving. So what would it take to make ColdFusion even more alive this year?
Less negativity, maybe. Do you know what I mean? It always surprises me that there are several members of our community that have threatened to leave over and over again, but still keep coming back to just, you know, put the shiv in, as it were, give it a bit of a twist, just to see if they can truly make the whole environment dead. I would just say a little less negativity. And if people want to continue working with ColdFusion because they enjoy it and they find it useful, more power to them. They should be encouraged to use it, and the community should be more about helping each other rather than denigrating various aspects of it. So I find that often difficult to rationalize these days. I'm a little bit better at handling that sort of thing, but certainly one of the things that people could do would be to support those endeavors that actually add value to their community. So one obvious example is Lucee. So there's all sorts of ways that you can support Lucee, whether that's doing documentation or just helping out on the forum, all the way through to actually making some kind of financial contribution. Because of the type of organization that we are, Lucee Association Switzerland, it's worth having a quick 30-second thing about that. The Rilo thing was a commercial entity, and they got into, I think, to be fair to them, the shareholders in that particular environment had a falling out, which led to a kind of paralysis of the code base. And that's why there was a need to kind of fork that code base and to make a new open source community. And from the very beginning, the focus for Lucee Association Switzerland was to be, it is a specific structure called a Swiss Verein, which is like an association or a union, could be a chess club, could literally be a trade union, could be a law firm, but all of these things sit in a not-for-profit kind of bubble, which means that we have to spend everything that we get on specific things that are relevant to the membership, which in this case, the development of Lucee. So we wanted to have a custodial entity that was absolutely not-for-profit, was totally focused on ensuring the community was healthy and promoting the ongoing development of the underlying language. And we have that. And you're at that kind of situation where any financial contribution actually has a significant impact on our capacity to address issues, build new features, improve compatibility with Adobe ColdFusion, just improve our community overall. And those standing members of LAS, there's nothing particularly special about them, except for the fact that they contribute financially and also contribute in many instances with resources and staff in terms of making overall Lucee community a success. I should say there are several members now that actually just have a financial contribution. They've said, look, we want the community to be healthy. We don't have the time to contribute in the sense of like, true open source contribution, but we're happy to see that the money that we might otherwise have spent, say, on an Adobe license can go towards improving the overall engine compatibility and health of that community. And we are at a time where any contribution at all has a significant impact, and people shouldn't underestimate how much their contribution could mean to the community as a whole. So I've just put that out there. Obviously, the president hat on and everything else, but it's something that we believed in strongly when it was first floated, and we contribute not only our financial kind of stipend for membership, but also significantly in terms of resources and our representation on the management board and managing the official Lucee images, contributions to the community, and so on. So yeah, it's good. I think it's healthy. It makes actually makes the development team, they like contributing to open source. We give them the time that they need, not just to Lucee, but to other enterprises. If you're going to use those products, giving back, even in a small way, is always good karma, I think.
Yeah, I would say that, and everyone can give back in some way. If you can't contribute to the code, you can do something with the docs, or you can help spread the word on to other people.
Yeah, that's right. Or just say just say nice things. Just say, oh, I really enjoyed doing that, or thank you for that. That has a big impact on people too.
Or even what Brad Wood has been doing, which is if there's like some third-party thing that says, hey, we work with PHP and Ruby, getting them to say, yeah, we work with ColdFusion too.
Brad does amazing. I have to say, Brad does amazing stuff. He's a tremendous advocate for CFML in general, and Lucee in particular. But yeah, I think the whole Ortus team are actually tremendous advocates in that area. So yeah, it's great that they make that contribution. It certainly takes a lot of time, a lot of effort.
Yeah, it does, but it's worthwhile. So
it's definitely worthwhile.
Great. Well, thanks so much for being on the podcast, Geoff. If people want to find you online, how can they do that? You can get me on, I think the only social media I'm on these days is Twitter, but I regularly check that. So that's @Modius, @MODIUS. You can always check out what Daemon's up to. You can go to the Daemon website, but we have a kind of a blog site called labs.daemon.com.au, labs.daemon.com.au, which I'm always checking, so always working with that. But also, equally so, I'm regular on the Lucee dev forum, so dev.lucee.org. You can catch me online easily enough. If you were super keen to do something with Docker and you want to engage Daemon, always feel free to contact us through the website or modius@daemon.com.au. Thanks. Fabulous.